Anyone knows what whole numbers are? We have some numbers called natural numbers. These are the counting numbers. If we said to you, can you count how many people in the classroom? What's the first number you start with? 1. So counting numbers does not begin with 0. It's always 1, 2, 3, 4, all the way to infinity. These are called natural numbers. Whole numbers, that's when you add the 0 to that list. Zero, 1, 2, 3, 4, and so forth. So we're going to be dealing with these numbers. How do you add and subtract these numbers? That's what the topic here. No decimal, no fraction. Each one of these, we have a whole chapter on decimal numbers. We have a whole chapter on fractions. Don't worry, that's coming. Chapter 2 is fractions. For those people who can't wait for them. You know? But right now, just whole numbers. There's a few properties about adding. We should know what they are. And one of them, I'll just write them down and I'll tell you what they are. We'll call this the identity property of addition. And what the identity property of addition is saying, if you take a number and add 0 to it, guess what the answer is? What is it? The same number. If you get $5 with you, and I say I'm going to give you nothing, how much money you still have? 5. Or if you reverse it, if you get nothing and I give you $5, how much money you have now? The number. That's called the identity property of addition. Any number, if you add 0 to it, the result is the number itself. So 3 plus 0 is equal to what? 3. 0 plus 7 is equal to what? 7. 0 plus 50 is equal to what? 50. 75 plus 0 is equal to 75. So if you take a number, add 0 to it, stays the same. It doesn't change. That's known as the identity property of addition. Another rule I'm going to list, I'm only going to probably 3 rules here, then we'll start talking about adding. It's called the commutative property of addition. Oh, don't turn sideways. That's an O here. And what is that? The commutative property of addition. I usually have little names for them because that's too much. It's a mouthful. I call that commutative property of addition, CPA. And that rule says, you know what, if you want to add 2 numbers like A plus B, it really doesn't matter which one you write first. That's what that rule is. So if I said to you, I don't want you to add 3 plus 2, but 3 plus 2, write that using commutative property of addition. 2 plus 3. If you flip-flop them, it doesn't change anything. It's the same answer. 2 plus 3 is 5. 3 plus 2 is 5. I call them CPA. The reason I like to call them CPA, to me, stands for change position. And A for addition. Change the position of the numbers. So I remember them that way. CPA, C for change, P for position. If you change the position of the numbers, it doesn't change the value of the two numbers. This is kind of important down the road when you start adding numbers. And let's say you want to add, and I'm jumping the gun here, 3 plus x plus 2. And I say clean that. If you look at these two numbers, we can apply that CPA rule. It says, if you get x and 2, you can flip-flop them. It doesn't make a difference which one you write first. So you can write that 3 plus and take x plus 2 and make that what? 2 plus x. I use the CPA rule, change position. Now, wait a minute, I can combine the 3 plus 2, make that one number. What's 3 plus 2? 5. So I can write that 5 plus x. That's where we're going to go with that down the road. But I just want people to know, I can move them around. I can write this one first and this one second. It's not going to change my answer. That's called commutative property of addition. And we have a lot of uses for it, especially with those type of problems. And the next one, the associative property of addition. It's still writing here. I'll leave it there and I'll just write under it. Those are the boring ones. We have to know the names for them. I call that APA, Associative Property of Addition, APA. And what the rule is saying, if you want to add three numbers, A plus B plus C, that's the same as A plus B plus C. What do you notice about those numbers? About the expression I wrote, and I rewrote it again. I noticed two things. One of them, that the order of the three letters, A, B, and C, never changed. A, B, and C, still in the same sequence. See, the A is still first, B is still second, C is third. The only thing that changed is what? The parentheses. Here I'm grouping the first two. Here I'm grouping what? The last two. APA, adjust parentheses if you want to. What does that tells me? It says if you have three numbers and you want to add them, let's say I gave you this problem. What is 3 plus 5 plus 7? It really doesn't matter which two you add first, because this rule says you can take the first two numbers and add them first. Remember, you got to do what's inside the parentheses first. That's coming up later, order of operations. PEMDAS, some of you might remember that. What's 3 plus 5? 8. You got to do that first. What's 8 plus 7? 15, right? This rule says, you know what? You don't have to add the first two numbers. If you don't like the first two, you can add the last two first if you want to. 3 plus, what's 5 plus 7? 12. What's 3 plus 12? 15. So regardless which two you add first, your answer is not going to change. Again, this method is called the associative property of addition. The order of the numbers stays the same. The only thing we're doing, we're just adjusting the parentheses. We're moving them. Okay, I'm done with the boring properties. How do we add numbers? Let's take some numbers and add them. Then I'll give you some examples where we add numbers. Here's a couple of numbers, 2, 3, 9, 4. Now I want to add to it 5, 1, 7, 2. What is the key to adding numbers? Let's say I'll put another number here, 6 here. I made that number one more digit here. What's the key to adding these numbers?
Finding the value.
What is it?
Finding the value.
What do you mean by that?
Putting the comma where it's
You could put commas. So I think what you're trying to say to me, maybe you want to line them up on top of like the ones on top of the ones, the tens, because you're not going to add, if you have 2 piles of money, one has a lot of ones, one has a lot of tens. You don't put the ones and tens, go, I got 5 ones and 5 tens. Oh, I got 20 tens. You can't add them. The ones and the tens are separate. If you have a pile that has 5 ones and this has 3 ones, you put the ones together. You take the tens from here, put them with the tens from that, you combine them into another pile there. So that's what we're going to do. We're going to line these up from the right side because that means the units will match. So when you line them up, notice the ones on top of each other, the tens on top of each other, the hundreds, the thousands, the 10,000s if you have any. So what's 4 and 2? 6. What's 9 and 7? 6 carry 1, right? 1 and 3. 4 and 1, 5. 2 and 5. 7. 6 plus nothing. So that will make it 67,566. Let's say I want to add 3 numbers. But it doesn't matter if I'm adding 2 or 3 or 50. The key, line them up from the right side. I want to add 9, 8, 2, 4 plus 3, 5, 6 plus 2, 9, 7, 6. Again, line them up. 9, 8, 2, 4, 6, 5, 3, 6, 7, 9, and 2. And if you want, since there's no number here, what can you put there? A 0. So if you like to make them the same size, you can. 4 plus 6, 10 and 6, 16. 6 carry 1. 1 and 2, 3 and 5, 8 and 7, 15, right? 1 and 8, 9 and 3, 12 and 9, 1 carry 2, 2 and 9, 11 and 0, 11 and 2, 13, 13,156. Now you might say, where am I going to add numbers like these? Okay. Let's say you have in your checking account, you have $2,174. And you get paid tomorrow. So you went to the bank tomorrow, or you went to work and they gave you a check, which is $513. Assume there's no penny here. You want to deposit that into your account. And while you're there, you know what? I had one of those tickets with me, scratch ticket. And can you check that? The guy said, oh, guess what? You won 500, there's color prize on it, and $29. So now you want to take this money, add it to your previous balance. How much money do you have? Well, you add them. You go 2, 1, 7, 4, 3, 1, 5, 9, 2, 5, and you just add them. 4 and 3, 7. 7 plus 9, 6, carry 1. 1 and 7, 8. 9, 11. 1, carry 1. 1 and 1, 2. 7, 12. 2, carry 1. So now your balance becomes $3,216. You can have fun with this. You know what? What about if I get my tax refund this week? $2,333. You can add that to this number. You know? That's how you figure actually where we use addition. Now, if you start making payments like rent, then what do you do with that money? Subtract. Electric bill, subtract. That's coming up next. So let's look at subtractions. We're still in the same section. We'll use this example. We said you have $3,216 in your account. Guess what? You got a rent due tomorrow. So you write a check for them of $675. So how do you find your new balance now? What do? Subtract. Because they're going to take that money away from your checking account. 3, 2, 1, 6. Subtract from it 5, 7, 6. Again, we are going to subtract here. 5 from 6. Is that a 1? 7 from 1. Can't, right? So you're going to come borrow 1 from this. This becomes 1, and that will turn to 11. 7 from 11. 4. 6 from 1. You can't. Got to borrow 1 from this. This becomes 2, and this is what? 11. 6 from 11. 5. 2. $2,541. Again, that's your balance. You go, I forgot. I got to pay the utility. I got to pay our car loan. I got to pay my $329 car loan. So let's subtract that. Line them up. Nine from 1. Can't. 3, 11. 9 from 11. 2. 2 from 3. 1. 3 from 5. And nothing from 2. $2,212. In some cases, sometimes you have a problem where, like this one, in your checking account you have $1,007. And now you want to pay electric bill of $89. You go 9 from 7, you can't, right? You got to borrow 1 from this, doesn't have it. From this, doesn't have it. You got to go all the way to this. So this becomes what? 0. This becomes what? 9. This becomes 9, and this becomes 17. 9 from 17. 8. 8 from 9. 1, nothing from 9, 9. $918. So you have to go all the way here to borrow 1 from that. So that's how we use subtractions. Now, there's one more thing in that chapter, and that's estimation. A lot of times, you're just trying to get an idea how much it's going to cost you to buy stuff. So let's say I'm redoing my house. My kitchen is a mess, and I say, you know what, I'm going to do my kitchen. And where are we going to go? Manny's, appliances? Lowe's. You can go to Lowe's. Manny's, Lowe's, any place you want to go to. We need dishwasher. They go dishwasher is $529. We need fridge. $11.52. We need stove, oven, stove, whatever. $513. Microwave. $275. If the problem says estimate, that's the key, estimate. How much would it cost you to buy these? Now, you in the store, and in your head trying to do a quick math. You don't have a piece of paper. What you might do is, the key to that, not you might, you want to do that, is to round these numbers first, then add them. And in this case, because you're looking for a quick estimation, maybe you want to round them to your nearest 100, because that'll make the math quicker. So nearest 100, there's the 100th location. That's this one. Remember the rule of rounding. Look at that number. Is that 5 or more?
No.
Don't change that one. And the rest are zeros. Nearest 100, that's this number. Is that 5 or more? Add 1 to this. Nearest 100, that's this one. Is that 5 or more? No. 500. Nearest 100, that's this one. Is that 5 or more? Add 1 to this. 300. And now add these numbers. That's called estimation. 0, 0, 5 and 2, 7 and 5, and 3, 5 carry 1, 1 and 1, 2. So we're looking roughly $2,500 to buy these appliances. Again, I'm not looking for the exact number. I'm looking for a neighborhood. If you want to know exactly how much it's going to cost you, then when you go home, you take a piece of paper and you go 529, 513, 275, and you can add these numbers. 2 and 9, 11. 11 and 3, 14 and 19. 9 carry 1. 1 and 5, 6. 8, 9. 9 and 7, 16, right? 1 and 1, 2. 7, 12, 14. Notice I said approximately 2,500, 24.69. How far was I? $31 off. If I'm spending $2,500, do you think I'm going to lose sleep over $31? So that's what estimation is. You need to round the numbers first, then do the math. Sometimes instead of the word estimate, they go about. About, that means another way of saying estimate. So if you see the problem going about, how much? That's the same as estimate. Round the numbers first, then do the math. You do a lot of estimation all the time when you're shopping. Unless you have $100 in your pocket or $50, you want to make sure you don't go over that. So as you go and you're buying stuff, you go, oh, these apples $2.99. You go $3. This orange is $1.75. That's two more. That's $5. So we do the estimation all the time when we shop, and just to make sure we don't go over the budget that we have with us.